Welcome to Oil Tech Pro. We have been on this series of fundamentals of reservoir engineering. We have been considering the session on properties of reservoir rock. We have considered the porosity of reservoir rock. We have considered the permeability. We have talked about capacity of flow. We have looked at transmissibility. We have considered the resistivity and conductivity of reservoir rock. Today, we are going to look at a critical topic, which is compressibility. The compressibility of reservoir rock. Before we delve into compressibility, there are certain things we need to know. That this reservoir rock are overlaid by various rocks with various weights, which we call overburden. Overburden pressure, which is subjected or acted upon on the reservoir. This overburden pressure contributes a lot to the external force or external pressure on the reservoir, and we need to determine for this. The conditions necessary for overburden depends on the nature of the rock. It also depends on the depth of the formation where we find our reservoir, and also depends on the age of that particular rock. But among all these, the most salient is the depth of the rock, of our reservoir rock. Now, if the reservoir rock is found at a depth of, let's say, 10,000 feet, the overburden pressure we take as 1 feet per psi. Okay? So we consider our overburden pressure at 1 psi per feet. Overburden pressure, the gradient for overburden pressure is seen as 1 psi per feet. What this implies is that for every 1 feet which we cover, we will encounter 1 psi of force. So if this is actually true, that means at 10,000 feet, if we find our reservoir at 10,000 feet, the overburden pressure, OP, will be equal to 10,000 feet times overburden of 1 psi per feet. This gives us our overburden pressure is equal to 10,000 psi. Good. This is the external pressure which our reservoir rock is subjected to. We also have the pore pressure. The pore pressure is also called the reservoir pressure, and it's also called, we can call it the reservoir pressure, the pore pressure, okay, or the void pressure. And this is approximately 0.5 psi per feet. So the gradient for pore pressure is usually 0.5 psi per feet. Now let's come to this 10,000 feet reservoir rock where we find our reservoir. The pore pressure for this will be what? 10,000 feet by 0.5 times 0.5 psi per feet. Sorry. Cancel this. This gives us what? 5,000 psi. Okay? So that means our pore pressure is usually written as Vp is equals to PV is equals to what? 5,000 psi. Okay? Now, normal pressure of the reservoir rock. The gradient for normal pressure of the reservoir rock is approximately 0.43 psi per feet. Okay, so this is the normal pressure, this is our pore pressure gradient, and this is the overburden pressure gradient. There is a difference or differential between the overburden pressure minus our reservoir pressure, or we call it P subscript R, depending on how you want to write it. You can write it as a ROP or P subscript R. If you subtract this, for this case scenario, we have that at 10,000 feet, our overburden is 10,000 psi minus the pore pressure of 5,000 psi. There is a difference of 5,000 psi. This difference is called our net overburden pressure, NOBP, net overburden pressure. The importance of this is that if this net overburden pressure is high, why will it be? If it's too high, it will affect or influence the porosity and cause the porosity of our rock to be altered. And the porosity will also affect the permeability of the rock. Okay? And if that happens, of course, you know that we will have what we call our pressure depletion. That means pressure depletion is taking place. And that occurs during what? Production. Okay? So, giving us a compressibility of the particular rock formation. The rock is being compressed. Okay? And the void spaces where our fluid are supposed to be contained are subjected to compression. And if we want to calculate for compressibility, we take compressibility based on this overburden pressure. Compressibility is equal to 1 over Vp, the pore volume, over the differential of our pore volume over difference of our pressure. Okay, so you see that compressibility is a fractional change, rate of change of our pore volume over unit change of pressure. This is for compressibility. There are 3 types of compressibility. We have compressibility in terms of the bulk compressibility. The bulk compressibility, where we are looking at the entire bulk of the reservoir rock. We can consider compressibility in terms of the grain or the matrix compressibility. And thirdly, which is the one we just talked about, we consider in terms of the pore volume or pore compressibility. Okay? Most times, this is the one that we actually consider when we are looking at our reservoir rock. Now, this can also, because the pore volume is directly connected to the porosity of the rock, we can substitute the pore volume with, there is a negative sign. Okay, so if we consider it in terms of the porosity of the rock, we can have this equation to become 1 over porosity, and the differential or the difference, the rate of change of porosity over the rate of change of pressure. Okay, so we can use this formula, this equation, or we can use this equation to determine for compressibility. Join us subsequent classes as we discuss more on the fundamentals of reservoir rock. Thank you.